Hi guys, I'm back. Of course, you noticed that I'm wearing the same thing, same hairdo. It means today is still another marathon day for me. So now what we're gonna do, we're gonna study chapter 27. It's our last chapter. It's 27. It depends actually on the book you're using. So it might be another number, but the title stays the same. It's the process of economic growth. Okay? It's things we have studied before and we're adding some to it. So first, we're going to see part A, which is theories of economic growth. First, we need to have the definition. What do we mean by economic growth? Economic growth, it's when you increase what you can do, which is your potential GDP, okay? So it represents a country's expansion of potential GDP, national output. Definition, I'm gonna read it. Economic growth represents the expansion of a country's potential GDP or national output. This is taken from the book. It's simply an outward shift in your PPF. Do you remember that PPF, the production possibility frontier? So when you push that frontier, you are actually growing. Okay, so we want to increase the GDP, but at the same time, we want to increase the GDP per capita. The GDP per capita, it's simply you take your GDP, you divide it over the population. It gives you how much, in average, what each person's share in the GDP. If it increases incomes in the country. And if it increases incomes in the country, it increases your living standards in the country, which is one of the aims of macroeconomics, making everybody having more. Okay, now what drives that growth? You have the 4 wheels of growth that we have already studied. Well, we had 3, now we're adding technology. So human resources, which is your labor, you want to have a good number of the size of the human resources you have should be big enough, and you want the quality of that labor, okay? You want them to be able to do what is needed from them. Natural resources, so arable land, oil, whatever, all the what nature gives you. Capital formation, so you need capital. Do you remember what we mean by capital in economics? In economics, it's not the money, but what you do with the money. It's actually investing in capital goods, which means machinery, etc. Do you remember that? Durable goods produced in order to further production. That was your definition of a capital. Okay, so how do we get capital? We did it in an earlier chapter. We need to sacrifice part of current consumption in order to invest in those machines, etc. Okay, so increase investment in durable goods that can produce by sacrificing your current consumption. This way you shift outward the PPF. Okay, and now we're adding technology. Technology, actually, the role of technology is to help you produce more with what you have. So with the same resources, you can produce more. That's also an outward shift in your PPF. So now if we gather all these factors together, our human resources, our natural resources, our capital, and our technology, we make them work together, it gives us a certain production function, okay? That's called the aggregate production function, because right now we're not looking at one company, we're looking at the whole nation, at the whole country. So the aggregate production function is written as, so the output that you're gonna have, the real output, it depends on a function of K, L, and R. A being the level of technology you have in the country. So with a given level of technology in your country, you have a function, a way to put together your capital, labor, and natural resources, and it's going to give you a certain output, okay? So if inputs increase, your quantity increases. logical. And if your level of technology increases, the output also is going to increase. Clear? Okay, I wrote this APF differently than this one because this one is level of technology and this A here is aggregate, okay, to make the difference. Now, if I look at the production function, I forgot to put the graph here, I should have. Here you have your inputs, and here you have your outputs, and it's going to go this way. We're going to study it a bit deeper in the neoclassical model. For now, we're just going to put it this way. Okay? Now, first theories of growth, we're going to see the classical dynamics of Smith and Malthus. We're going to start with Smith. This is a little story. Prepare. Did you drink your milk before sleeping? I'm going to count. I'm going to give you a little story. Not count. Narrate. Okay, Smith. Smith considered a golden age where land is free and available. Okay? At that time, technology was quasi-null. No technology. Okay? Capital, machinery, not really. But we had natural resources, and here he considers land and labor. Okay? Land is free and available. So I want to go work the land. So I'm going to come. I created this. This is the land. So let's imagine this land is producing 1 point. That's how much it's producing. Then somebody else comes. That person. Is that person going to come to my land? No, land is free and available. That person is going to go to another piece of land. Okay? So that person, we're all working the same, so that person is going to produce exactly the same amount as I do. Land is free and available. Another person comes, takes another piece of land, producing the same amount, etc. Okay? So according to Smith, if you double the labor, you're gonna double the output, isn't it? So if I have a PPF between two goods, X and Y, I'm producing 50 of X and 100 of Y with labor 2. Okay? 2, that's what I'm producing. If I increase the labor by a certain proportion, here I'm going to double it. According to Smith, I'm going to double my PPF. 200 to 100 here. Okay? I'm giving you here the labor. If you increase the labor by a certain proportion, you will increase the output by exactly the same proportion. Because land is free and available, we don't have to squeeze in it. Okay? Okay, Mr. Malthus, that's little b. Said, even though land is free and available now, it will not stay free and available forever. Ultimately, we will have to squeeze. So, for Malthus, land was free and available. Okay, following Smith's model, it's gonna increase by the same proportion, but then at a certain moment, all the land will be ultimately occupied. So, now if we add the labor, what's gonna happen? Here, you're doubling the labor, but you're not doubling the output. Okay? Because they have to squeeze in the same land. So, you double the labor, you don't double the output. Which means you're going to increase the output by less than the labor increase proportion. So for Malthus, you're not going to come here. It's going to be less than doubling. Okay, I use double as an example. Okay, guys? So for Smith, remember, he considered a golden age where land is free and available. So if we double the labor, we actually double also the land. We're gonna use do you remember the constant returns to scale? We double the labor, they go to other pieces of land, which means we double the output. For Malthus, no, land is not gonna stay free and available forever. So we need to, even if we increase the labor by a proportion, because we didn't increase the land too, so the increase in output will not be proportional, it will be less than proportional. I hope it's clear. Now I'm moving to the neoclassical model. Unfortunately, as I only have one board, I couldn't prepare it. Take a screenshot because I'm gonna move on. Done? Yes, not in the picture, I'm not in the picture. Go ahead, take your screenshot. Done. Okay, the neoclassical model was created by Robert Solow, and he got a Nobel Prize in '87 for his contribution to this, and I think game theory too. Anyway, let's move. What was that? That's number 2. The neoclassical model. Neoclassical, one word or 2 words? One word here. Neoclassical, one word. Classical model. And here we're gonna talk about Robert Solow's theory. Robert Solow. Okay. Robert Solow, MIT. Okay. Now, the neoclassical model actually considers one concept that is called capital deepening. Okay? Capital deepening. Deepening. Okay. Capital deepening simply means give to the employees more capital to work with, more machines to work with. Okay? So it simply means increasing the K/L ratio. K/L, capital over labor. So for each employee, you're going to have more capital. But you're not increasing it by decreasing labor, you're increasing it by increasing capital. Okay? Because there are 2 ways to increase a ratio. Decrease the denominator or increase the nominator. Here we're only going to increase the nominator. That makes sense. Okay. Imagine I'm making coffee. Okay? You give me 1 coffee machine, it makes 1 cup. So while I'm making 1 cup of coffee, I'm waiting, doing nothing. Waiting for the coffee machine to fill in the coffee. Now, if you give me 2 machines, I'm gonna put the first one making coffee. While it's making the coffee, I'm gonna put the other cup in the other machine. If you give me a 3rd machine, I'm gonna produce even more because now I don't have any idle time. I have more machines to work with. Okay? Let's study what he says. So first, what did he consider? He considered labor as being a given. It doesn't change that much. Labor given. Natural resources are given. So he only considers K and L, and later on he's going to consider A. But for now, we're not going to take A into consideration. So for him, right now, it's F, K, and L. So we can influence K L is, we can't really influence it. So we're gonna work with the K, which is capital. K over L, capital to labor ratio, I talked about it. Yes, I'm cheating to know what I have to do. Now let's look at his APF. APF, this is according to Robert Solow. So here is my labor, I'm sorry, my K over L. And here is my Q over L. This is your productivity per labor. So for each worker, how much quantity they are producing. And here is the input, which is the capital per labor. Okay? We're doing it for one labor. Okay. So I'm going to start from here. I don't know where it starts, so I'm not going to put the 0. I'm just going to go this way. Well, 0, 0, but I don't know how it's going to go. Okay. The more capital you give to a person, the more productive it becomes. Okay? The more machines you give, the more productive it becomes. But let's imagine the example of coffee machines. You're giving me more coffee machines, more coffee machines. Now you gave me 10 coffee machines. I'm running between coffee machines. I don't have a second to myself, okay? If you give me an 11th one, I'm not even gonna be able to touch it. So even though you give me 11 machines, I'm gonna produce exactly the same amount because I have 2 hands. So you keep increasing the capital per labor, but at a certain moment, even though you increase it, the output is gonna stagnate. Okay, I'm sorry for my hand. It's not easy to work on this board. Okay, this is stagnation. Okay, so is it useful to give me more machines? I don't even touch them. This is what he calls the steady state. So here we stopped increasing the output per labor, so we are entering a steady, it's with an A, steady state. So here it's useless to go increasing. Okay, useless, because you're giving them machines, they're not touching them. So now we're gonna put technology into play. So if we once we get into the steady state, what should we do? Instead of continuing capital over labor, increasing the capital, we deepen the capital. What we're gonna do is change the technology. Okay, now instead of giving me an 11th machine, you're gonna give me another machine, but this one I just press a button and it gives 2 cups automatically. It's done. So I have more time, I can work even more, and you keep deepening my capital. And I keep working even more till I reach the steady state. When we reach the steady state, invest in a better technology again. Okay? So, according to Robert Solow, now here, when we come to the steady state, we actually invest in a new technology and keep deepening till we reach another steady state. Do you see it? Then again, invest in a new technology. So you're actually shifting up your APF. So APF 1, APF 2, and this is the effects of technology. Okay? So now we need the function becomes a function of K and L. Natural resources, they are given, they don't change, so we don't put them in this function according to Robert Solow. I hope you got that. Now, is technology important? Oh yes. Technology helps you shift out your PPF. It helps you, which is another way of seeing it, shift up the APF. It increases your productivity. Okay, so is it important? Important, yes. Importance of technology. I'm writing it big because it's very important. Okay, the problem with technology is very, very hard to produce. So I'm gonna write it here, hard to produce. That's my dog playing. So it's very, very hard to produce. You need research and development. You have to invest tons of money to create technology. But it is really hard to produce, but really easy to reproduce. That's the problem with technology. You create technology and somebody else just copies it. You did everything you could to create it, money, time, effort, and then somebody just comes, copies it. What are you gonna do? Especially your investors. They're gonna stop investing in creating technology, while technology is so important for the growth. So we need to make it harder to reproduce by making laws, okay? Patents, copyrights, all that stuff, okay? So next time that you buy something cheap that costed a lot of money to produce, you need to feel guilty because it's not good. You're not helping the nations who created it or our own nation when it creates technology. If you copy it for nothing, you're not helping the growth, okay? So that's what we have here. Moving on, technological change as an output, yes. Well, technology is an output of the economy, and at the same time, it becomes an input, okay? So please remember that technology is really, really hard to produce. That's why we need to protect it. Moving on to part B. I hope this is understood. How am I doing with time? Oops. I don't know what's happening in here. I don't know. I'm gonna continue. It was telling me it's low on battery. I know it's low on battery, but I have to finish. Oh, okay, part B. Yeah, I think this is gonna be the last video today because I have no battery. I'm gonna do it quickly. Okay, part B. You need to read the 7 patterns of growth. 7 patterns of growth. I told you you're going to be responsible on a part, and that's the part. It's simply reading it. It's actually patterns of growth and 7 patterns of growth. It's in the book, you have to read them. Okay, now I'm going to the growth accounting approach. Accounting, I hope it doesn't stop. Accounting approach. Okay, the growth accounting approach simply calculates the percentage growth in output according to labor and capital. Okay, so percentage Q produced, Q growth, percentage growth in Q. I'm gonna put it QG or GQ. No, I wrote growth. This way it's easier. Is equal to percentage labor growth times the weight of labor plus the percentage capital growth times the weight of capital plus your level of technology. Where am I? Yes, plus TC, which is technological change. I'm gonna give a small example because I don't have time and I think my video is gonna stop. Oops, you don't see anything. Do you see anything? Okay. I need to finish. Here they're giving you an example in the book. So they're telling you that, by the way, TC can only be inferred. It has to be given, or you have to have these things. These are easy to get from the from the data, and then infer TC, okay? Technological change. It's also a percentage. Okay, let me see. Technological change 1.5%. Labor growth, where is it? Labor growth at 1%. And labor weight is 1/4. If it's 1/4, the capital is 3/4, okay? Capital weight 3/4, I know. Oh no, it's labor that is 3/4, so capital is 1/4. But what is capital growth? Capital growth is 4%. Capital growth equals 4%, and capital growth is equal to 1/4. They have to, the sum of them needs to be equal to 1. Okay, so simply replace here 1.5% plus labor growth 3/4%, because it's 1% times 3/4, and capital, it's going to be 4% times 1/4, so it's going to be 1%. So it's going to give you at the end Q growth. I'm doing it quickly, I'm sorry guys. So 1 plus 1, that's 2.5. 2.5 plus 3/4, that's 3%, isn't it? 2.5% plus 3/4, that would be 3/4? 0.75%? Ah, 3.25%. I might have a problem with calculation here. Do I have my answer here? No, I don't have it. Of course I don't have it. That's the last thing we're gonna study, guys. So I'm gonna 3 divided by 4 is equal to 0.75 plus 2.5. I put, okay, 2.5. 2.5, what am I doing? I think it's correct. Okay, guys, love you. I hope it recorded the previous thing because I don't want to redo my job. Bye.